This is the brief on low-level optimization. We're looking at managing CPU registers and memory to squeeze the absolute maximum performance out of your code, cutting out those invisible micro-delays that just kill processing speed. First, let's talk about branchless selection. Think of the blend function. Instead of stopping the CPU to make a decision with a traditional if statement, it uses a bitwise mask. It's kind of like a stencil using logic, specifically mask and yes versus not mask and no, to filter the right answer. Why does that matter? Well, it means the processor computes outcomes without a brunch instruction, guaranteeing a strictly constant execution time. Second, we have in-register transposition. Look at the transpose function for 4x4 matrices. This physically reorders data, taking 4 row vectors and interleaving them right into 4 column vectors. But the real kicker? It does this entirely within the ultra-fast CPU registers, so we completely avoid slower memory operations. Finally, there's prefetching on the Titan P2. You know main memory, or RAM, is sluggish compared to the CPU. So the prefetch read instruction commands the memory controller to grab data for the L1 cache ahead of time. The result? By the time your physics calculation actually reaches that address, the data is already there, waiting for you. So the bottom line is, to optimize at the lowest level, you gotta minimize branching. Keep your matrix operations inside registers and preload data into the cache before the CPU even asks for it. That's how you write code that doesn't just run, but literally flies.